Hello, everybody, and welcome to the last Fossil Friday chat of 2020. We made it!
Woo!
Um, oh, happy holidays, everybody. I'm Brittany Stoneberg. I'm one of your hosts of Fossil Friday chats, and I am from the Western Science Center. Joining me, as always, is my lovely co-host, Gabriel Santos.
Hello, everybody.
And today, for our last Fossil Friday chat of the year, we are joined by Peter Kloess. Peter, it's so good to see you.
Hey,
Peter,
everybody. Good to see you too.
my academic brother.
Oh man, how you doing, Peter?
I'm doing all right. It's end of the semester over here, so yeah, just happy to be wrapping up grading and looking forward to taking a little break. Yeah,
Aren't we all? Aren't we all just ready for a break from 2020, right?
Uh-huh.
we're getting there.
So close, so close. Well, if the viewers of Fossil Friday chat are not familiar with Peter's research, it is very cool, and I will tell you a little bit about it. So, have you ever been to the beach and marveled at gulls or albatrosses flying over the water? Now imagine one of those birds with a 20-foot wingspan. Paleontologist and UC Berkeley doctoral candidate Peter is going to join us today to talk to us about pelagornithids, birds that soared across the entire planet, grew to gigantic proportions, and had rows of fake teeth in their jaws. His research includes a recently published paper in the pelagornithid specimens from Antarctica. We have a lot of Antarctic connections lately here at Fossil Friday Chats. I'm not jealous. I'm a little jealous. Just a little.
Oh.
Believe me, I want to go to Antarctica. These are specimens I someone else collected and I got to look at them. So I'm jealous too. I want to go.
I'm very excited to hear about this after hearing about it from you for a while, and also I'm just very proud whenever I hear there's PhD candidate or yeah. Wait, did I say that right? Yeah, PhD candidate Peter Kloess, because like I said, we both went to the same school for our masters, and so I'm just very, very excited and proud to get to say that for my dear academic brother, and also see his papers being published. It's so cool.
Yeah. A little more about Peter. He's, again, a doctoral candidate at UC Berkeley, where his research focuses on the evolution and morphology, so the shape, of beaks in tetrapods, animals with 4 limbs. We've talked about tetrapods on this show before. You guys know what that is. Before beginning his doctoral studies, he completed his bachelor's degree at Montana State University, and just like Gabe and me in progress, he completed his master's degree at Cal State Fullerton. Woo,
Go Titans!
In between these studies, he has conducted fieldwork across much of the western United States as a mitigation paleontologist and associate with multiple museums, collecting a variety of fossils from Cretaceous dinosaurs to Pleistocene shell beds. Yeah, I am so excited, Peter. And again, congratulations on being a doctoral candidate at UC Berkeley. That is really cool.
Thank you. Yeah, I know it's a lot of fun. It's a lot of work, but yeah, I'm happy to be doing it.
Yeah, and if anybody has questions for Peter, as always, go ahead and drop them in the chat, and we will get to as many as we can after his presentation during the Q&A portion of our chat today. So, Peter, whenever you are ready, go ahead and take it away.
All righty. Well, I mean, I've always wanted to say this, so this is a great venue to do it. I'm a longtime listener, first time caller. So yeah, I mean, I very much appreciate this program, and I want to thank Gabe and Brittany for bringing me on board to talk about some of the research I've been doing. So yeah, so I'm going to focus on the pelagornithid side of my research, but if we have a chance, maybe we could delve into some of the other things I work on. Yeah, so for today's talk, this is all about pelagornithids, but I do want to start us with just a bit of my background, talking about some of my interests and some of my past research, because that really did bring me to the new research that Gabe was alluding to. And really, before we can even dive into some of that new research, we need to talk about pelagornithids all around the world. We'll talk a little bit about the oldest ones, the biggest ones, and certainly one of the youngest ones. So yeah, we're going to cover pelagornithids of all sizes, of all ages, and then we'll start diving into the research that my colleagues and I published recently. I think we're talking 6-7 weeks ago, and as was mentioned, these are Antarctic pelagornithids. So so just to give a little bit of background for where I'm from, I grew up in the Bay Area, in San Francisco, and I was one of those kids that was hooked on dinosaurs, very much a science nerd. And so that included going to museums like the California Academy of Sciences, the Exploratorium, if you're familiar with those venues in San Francisco. Just soaking up a lot of science. But also my family took a lot of trips to the beach. And while playing in the surf and sand, there was a lot of bird watching for me. And I think that's probably where my interest in seabirds really kicked off, is just at observations from sitting on the beach. After doing all of my primary schooling, I ended up going to Montana State University for my bachelor's degree. There's a lot of dinosaur research that takes place. And that's really what brought me there. Is I had this love of dinosaurs since I was little. And while I was there, I got to partake in excavations, spending entire summers digging in the dirt, looking for dinosaurs. So this is a picture from many years ago, far too many that I want to say exactly. But there at the yellow arrow, that's me. I think I probably have a small pick or hammer in my hand, and I'm just working away, trying to get a dinosaur bone out of the ground. So after I finished my my bachelor's degree at Montana State, I ended up taking a step away from academia and working in environmental consulting as a mitigation paleontologist. So that image on the left, that's not one of the sites that I was on, but that is, that's oftentimes that's what some of these sites would look like. You have lots of heavy equipment, moving tons and tons of dirt, and depending on the rock layers that they're working their way through, there's the potential for fossils to appear. And certainly here in California and a lot of the United States, there are regulations in place to ensure that should any fossils, and even beyond that, we can talk about archaeological artifacts, biologically endangered species, that you have specialists on site to help guard and protect these resources that are so rare. Like the easy way that I tell people what I do or what I did as a mitigation paleontologist is that I used to save fossils from bulldozers. It wasn't, to be honest, it wasn't that harrowing. I would not dive in front of a moving bulldozer, but I would certainly flag them down, ask them to stop, and allow me to step in, assess the situation, and potentially get some fossils out of harm's way. So that's what that image on the left-hand side represents, is just my time on various construction sites across the Western U.S., saving fossils from bulldozers. Yeah. So after many years doing that, I decided to come back to academia, and that's where I ended up going to Cal State Fullerton. For those of you familiar with Southern California, it's not all that far away from Disneyland. And while I was there, my master's thesis centered on a period of time from the middle Miocene to the earliest Pliocene. So we're talking about 12 million years of Earth history. And what I did was I assembled a data set of specimens. So I went to multiple museums, looking at fossil specimens, specifically focused on seabirds. So at this point, this is where my interest in paleontology and those observations of seabirds from being a small child, that's where I finally got to bring things together, and develop this thesis, looking at 12 million years of Earth history, trying to understand how the bird communities of coastal California changed over time and in relation to various tectonic and environmental events. So that's really where my master's came in. And part of that master's, as I mentioned, I got to go to multiple museums. One of them was the Santa Barbara Museum of Natural History, shown here. And again, for those of you not familiar with California, here's a map showing where Santa Barbara County is located. So it's that orange, off orangey brown kind of color, with the yellow arrow. So I got to visit the Santa Barbara Museum of Natural History, and this specimen certainly caught my eye. This is mounted to a wall in one of their exhibit halls. And what you see here is what we call a slab and counter slab, with a fossil specimen of one of these pelagornithids in it. So just to give some background, when under the right conditions, when an individual dies and gets sandwiched by lots and lots of rock layers, if those layers are split just right, you can actually get two slabs of rock that possess the fossils in both of them. So here we have, like I said, a pelagornithid in two parts mounted on a wall in their exhibit hall. And the specimen has already been described. So I'm not lucky enough to be the one to describe it. That honor goes to Hildegard Howard. She was an avian paleontologist from the Natural History Museum of Los Angeles County. And this was the paper she published in 1957, a gigantic toothed marine bird from the Miocene of California. And we use the term toothed in this sense, big air quotes, that these are not proper teeth as you or I have in our mouths. These are bony projections out of the jaw. So what you're seeing in this image, these are not the air quotes teeth of that Santa Barbara specimen. These are from a specimen from Morocco, but they give you a sense of what these bony projections look like, and the fact that they are attached directly to the bone of the jaw. So if I think I have a little cursor here, so you can see the tooth running up and down, and this bottom section here along the bottom there, that's the jaw that it would connect to. So your teeth, my teeth, are made of enamel and dentin. These birds have these bony projections, or these projections made out of bone. And if you look in this picture, you can see various grooves and pits. There's blood vessels that would have supplied the sheath made of keratin over top of that. Keratin is a material much like our hair and nails. So the composition of these pseudo teeth, as we call them, that's, it's a word that means false teeth. So the composition of these pseudo teeth is very, very different than, as I said, your or my teeth. To give some context for the timing of this specimen, so we're still talking about that Santa Barbara bird. This is just a very quick little timeline of the Cenozoic. Over on the left-hand side in the green, marked by the K, that represents the Cretaceous era. This is the end end time of the dinosaurs. So where you make that transition from the green Cretaceous to the orange of the Paleogene, that's what we call the KPG extinction. It marks that boundary. moving further to the right, you get closer and closer to the recent, to the modern times. So the numbers that run along the top there indicate how many million years before present we're looking at. Okay, and if we plot that Santa Barbara bird on here, this is in that middle Miocene period. So again, this is that time period that I was looking at for my master's. That's why this specimen was so important for me to look at, to include in my data set. Now, if we get a closer look at this specimen, so this bird here is called Pelagornis ori, named after one of the curators, former curator at the Santa Barbara Museum. So this is just one of the slabs. And to give some sense, because you may be looking at this slab and thinking, I don't know what I'm looking at here. Here we have the slab side by side with a picture of the wandering albatross. The wandering albatross is the largest flying bird today, with a wingspan over 11 feet, or I think it's somewhere about 3.5 meters. But again, you may be looking at this slab and still thinking, Peter, I don't know, I can't make heads or tails of this. So I've added a few annotations. So here, this is about where the eye is going to be located. We take this a step further. We can start seeing the beak coming out of this specimen. Here in blue, this is the upper arm bone, or the humerus. In green, we've got the bones of the forearm. So just, what you see here, the radius and ulna. In orange, we get to the wrist and the digits. If you're a bird anatomist, you might call that the carpometacarpus. And then in this slab, we also see the feet. Although in the wandering albatross picture, it's obscured by some grasses there. But yeah, so we come back to the slab picture, and hopefully, seeing these features called out maybe makes this a little easier to parse what's in the slab. And to give a sense of how big this specimen is, this is a picture of myself a few years removed from my master's, speaking with some of the staff members at the museum. That's one of the curators on the right-hand side, and I think in this picture I'm certainly pointing out the beak. I'm probably nerding out about the pseudoteeth and trying to explain what they are and express my enthusiasm and try to infect others with that enthusiasm for these teeth, pseudoteeth, excuse me. So that trip to Santa Barbara really sparked my interest in these pelagornithids. It got me excited to learn more about them. Once I completed my master's, I moved on to UC Berkeley, where I am now. And what you see here on the right-hand side, the T-Rex, this is kind of the iconic figure for the Museum of Paleontology at UC Berkeley. So I knew I was coming to Berkeley. I was trying to figure out what I was going to do for my dissertation. And one of our museum scientists showed me this fossil with the intent that this was going to be my entire dissertation, but certainly just to spark some interest, to get some research momentum. I was shown this. And so this is part of a dentary of one of these bony tooth birds. But before we get too deep into this specimen and the research that my colleagues and I just published, I want to take a step back and talk about pelagornithids as a whole. So this is a map of the world. This is from the Paleobiology database, and it may be a little hard to see here, but what we have marked out with the little yellow and orange dots are the various locations that pelagornithid specimens have been found. So, what you might see, or what I hope you are seeing, is along the west and east coasts of North America. We've got lots of specimens there. stretching down the Pacific coast of South America, places like Chile. There are also lots of pelagornithids that come out of Europe and Northern Africa. There's a few specimens from Japan, and stretching down the east side of the Pacific, we also get into Australia and New Zealand, and just at the tip of Antarctica, there's also some specimens there. So, we can move on to talking about one of the oldest, or actually it is the oldest pelagornithid specimen, Protodontopteryx ruthei. This is a specimen from New Zealand, and as we saw in the Santa Barbara bird, this specimen was also collected from a block. wasn't quite a slab and counter slab, but here on the left-hand side, we've got this jumble of bones that have been looked at and figured out what's what in there. But the feature that I think is easiest to call out here on the right-hand side are the top and bottom beak, with the arrows pointing to the various pseudo teeth present in this specimen. And this is a news article with a nice reconstruction showing what these birds would have looked like. So this Protodontopteryx would have had a wingspan about 1 meter long. It's approximately 3 feet. So that's the equivalent of a modern gull. And as I mentioned, it had these fully formed pseudo teeth. So if we look at our time scale and plot the specimen on here, Protodontopteryx was dated to about 62 million years ago, not that far removed from that KPG extinction. So if you think about it, we have the end Cretaceous event. Your big dinosaurs die out. A lot of life does go extinct. Many things still remain, and within a few million years, the first pelagornithids start to show up. We move on to some of the biggest pelagornithids. And this one, Pelagornis sandersi, is the largest. Here on the left, I've got just a still from a YouTube video titled "How the Largest Bird of All Time Stayed Airborne." I would highly encourage you all to check that out after this talk, of course. But here in the still, we can see just the approximation of what your average human, sized 6 feet tall, compared to what this bird would have looked like. So it's this bird, its body would have measured 6 feet in length, but the wingspan was closer to 24 feet. And the specimen comes from South Carolina. So yeah, this is a picture from the publication. Again, showing the size of that bird, with a silhouette of an albatross there for reference. So this gives you that sense. This bird was incredibly long-winged, if you will. At the bottom of this picture, you can see the limbs are incredibly long, and again, those pseudo teeth are very well represented here. So we move on and talk about Pelagornis chilensis. This is another big representative of this family of birds. This one clocks in about 5 meters in wingspan. That's about 17 feet. And here we have a picture of one of the authors as a scale bar, if you will. So you can see the specimen laid out with a human there for reference. Really can give you this sense for how big these birds are. And again, the pseudo teeth are very well represented here. Looking at the time scale, we plot these birds in here. Pelagornis sandersi is here in the latter half of the Oligocene. Pelagornis chilensis is in the latter part of the Miocene and stretching into the Pliocene. These ranges represent the rocks that these specimens came from. So we're starting to paint this picture of some of the pelagornithid diversity over time. We move on to one of the youngest specimens of this group. This is a pelagornis, but it's of an unknown species, and it comes from Santa Cruz County, which is not that far away from UC Berkeley, actually. This was a partial humerus, so the figure on the right, highlighted in red, shows you, again, that upper arm bone as part of the wing. Oh, uh-oh. I think some of my images aren't loading here. Let's see if that. Okay. Are you able to see any images?
No, let's try show anyway. Let's see
Show
if that works.
Yeah, there should be something there.
Well, we can move on, I guess.
Yeah.
We can't really see the picture.
Oh, that's a bummer.
Technical difficulty.
That's okay. Here, well, I mean, I'll narrate a little bit of what I can. So what I had shown in those slides was this specimen of that Pelagornis humerus. And I was giving some reference specimens there. So if you can imagine, so the first image I showed was actually a chicken humerus. So if you've ever had hot wings, this is like the drumette, and they're about this tall. If you're looking at my camera here, I'm showing with my fingers. This is about a chicken humerus. The next image had an albatross humerus, which was much larger, and then we got to this Pelagornis humerus, which is much larger still. And then I was going to point out the fact that it's not even a complete specimen; it's only half of a humerus. So that bird would have been quite large. Yeah. So my apologies for the technical difficulties there. But when we plot that specimen onto our time scale, it's the one marked here with Santa Cruz Pelagornis. This is a bird that's coming in at the very end of the Pliocene. This is one of the last pelagornithids we have around the world. So the notion that this specimen is at Berkeley, where I'm at. I mean, this is also helps fuel that interest that I have in this group. So we can bring it all back around and talk about that Antarctic specimen that was brought to my attention, after I arrived at Berkeley. And this specimen has an interesting history. As was mentioned at the very beginning of this chat here, I didn't collect this specimen. This was collected in the 1980s from a crew based out of UC Riverside. They traveled down to Antarctica on multiple expeditions, collected many fossils down there, of which this dentary, so part of the lower jaw, this is one of them. It was collected in the 80s, went to UC Riverside, and eventually, when that collection, when the faculty member who led those expeditions, when he retired, those collections moved up California, moved to Berkeley, and that's where this specimen and those other specimens reside now. So that's this bird as represented by the specimen, went on a very long trip just to make its way to Berkeley for eventually for me to take a look at. And so here's a map, just again pointing out where that locality is into Antarctica. To give a little bit more of a zoom in, this island where the specimen comes from is called Seymour Island. It's just off of the arm of, or the Antarctic Peninsula. So it's a tiny little island, but it does have lots and lots of fossils, of which this specimen is one of them. Oh man, I apologize for this. Another slide isn't loading here. But yeah, we can talk about this specimen. You know, one of the really nice things about the specimen is that it does preserve some of the pseudo teeth, and so I've pointed at them with arrows. Yes, they do look like little nubs. They're not as nice as we saw in Pelagornis sandersi or chilensis, or even the Santa Barbara specimen Pelagornis ori. This fossil specimen certainly was sitting on the surface and exposed to the elements, wearing down those pseudo teeth. But there was enough there that my colleagues and I could look at the specimen, take some measurements from these pseudo teeth, and not just the pseudo teeth themselves, but the actual spacing between them, as well as the dentary, the jawbone that sits underneath those pseudo teeth. And so here we have, we're showing Pelagornis sandersi on the top left, Pelagornis chilensis on the bottom left, and then our specimen over on the right-hand side. You'll notice the scale bars are all set the same to 10 centimeters. You know, with those measurements of the pseudo teeth, of the spacing between the pseudo teeth, and the dentary itself, we get a sense for how big this bird would have been if we had, if the UC Riverside team had come across it when it was intact. You know, the measurements really indicate that this specimen would have been of an individual with a similar size dentary as sandersi or chilensis. So one of these birds with an incredibly large wingspan, you know, something in the 5 to 6 meter ballpark, you know, upwards of 20 feet long. So that's where this comes about. Oh boy. I'm losing a lot of slides here. Oh no, I'm losing an entire section. Well, so I'll guess I'll narrate what was going on there. So that dentary, that's what sparked my interest in these Antarctic birds. Looking at that and trying to dig in a little bit deeper about some of the other Antarctic pelagornithids. There was another specimen at UC Berkeley called a tarsometatarsus. That's just a long-winded word for a foot bone, something below the drumstick. If you're thinking about your Christmas turkey, so we have this tarsometatarsus specimen, and other authors, previous researchers before my time, found that this is the largest tarsometatarsus of any pelagornithid found to date. But what I started realizing was that the stratigraphic placement of this specimen seemed a little off, and was a little bit younger than what the locality maps and the field notes were indicating. And that's where, in that same paper that we published recently, we brought all that evidence to light, and it turns out that it is, in fact, older than we had thought. So here as you're seeing on my time scale, I've plotted the Antarctic pelagornithids as that block sitting right above the Eocene. And so over that entire period of time, we have the two specimens that my team was looking at, but there's a handful of other specimens across that time range. And what we see through that entire time period is we have some of those giant pelagornithids as well as smaller ones. They're still big. Trust me, they're still big, but not as big. So what that tells us is that through the Eocene of Antarctica, we've got two different size classes of pelagornithids that were flying the skies, cohabitating, coexisting, and it also gives us this indication, as we had identified that foot bone to an earlier time period, that brings it closer to the oldest known pelagornithid to date, that Protodontopteryx ruthae, that gives us some indication that gigantism evolved much earlier than was previously thought in this group. So that's kind of what we missed out in those last slides that I apologize for weren't working. But that was the paper that came out recently. Like I said, just a few weeks ago, bringing to light those two specimens from our Antarctic collections and what that says for this group as a whole. And so with that, I just want to wrap up and say thank you to the Museum of Paleontology, and specifically Dr. Pat Holroyd for bringing the specimen to my attention, various other people for the conversations that we had talking about the specimen and the geology, people from other museums. Brian Chu was our artist, our reconstruction artist that I'll show you on the next slide, and certainly my lab members for hearing me rant and rave about pelagornithids for probably far too long. And then I also have various funding to acknowledge that supported me bringing this to an SVP past, as well as one of my other co-authors' funding sources. And so with that, this is the Brian Chu piece of work that he created for us, specifically for our paper. And so, big thanks to him. And I open this up for questions.
Thank you so much, Peter. That was so good.
Thank you. I'm sorry about those slides. I don't know what happened.
It happens. It's live. We're using Google.
It's the end of the year. It's Friday. We do what we can. It was still
really cool.
Yeah. Well, good.
Lots of really cool information. Like those birds. I don't even remember when I first learned about those birds, but they're just so weird that they have that like fake teeth in their beak, and that like they evolved like that after like evolving the beak, and they went back to the fake teeth. It's just so crazy.
I mean, it's incredible to think about. This is a group of birds that are definitely part of the crown radiation of modern birds. So this is a group that lost its teeth in the Mesozoic, and then with this family in particular, found a way to evolve pseudo teeth. It's even weirder when you think of it that way.
Yeah.
And they're also just incredible to look at, like the reconstructions, the comparisons that you were showing. There's still a part of my brain that can look at these fossils, can see them in front of my face, and think that can't be real. like there's just no way with the wingspan. Like my brain doesn't want to quantify it.
Oh yeah, I had written a piece to go along with the paper, and I was trying to find some size comparison to really frame like what is 20 feet, what does that look like, so people could understand it. And the closest thing I could come up with is if you take a 2-story house and put it on its side, that is basically 20 feet.
Wait, what?
Yeah. So if take that house, flip it on its side, and stretch a bird over that. That's a 20-foot wingspan.
I'm gonna need a minute here.
I know
I'm visualizing. Hold on, everybody.
That's crazy.
Yeah.
Oh man, that's a big bird.
Yeah, and as I mentioned, that Pelagornis sandersi from South Carolina, that got to 24 feet, so that's even bigger. Yeah.
So what you're telling me is Big Bird from Sesame Street is really a pelagornith.
Yeah, I mean, I would need to see. I would need to see his wings. I feel like he tucks them in a little too much for me to get a good guess at.
What the heck, Brittany?
I think I broke game.
Just a bit, but that's okay.
just a tad.
Oh my god, I'm not gonna be able to watch Sesame Street ever again now.
Yeah. I hope now some intrepid paleo artist on Twitter decides to do a reconstruction of Big Bird with a 24-foot wingspan.
That's terrifying.
And very sharp pointy teeth as well.
Oh, that's horrifying. But I also do want to see that.
We did at our so my museum does like air show event. We'll go to air shows because we're figuring like we'll go anywhere somebody will be willing to listen to science, will listen to us talk at them. So we've gone to air shows, and one of the things we did was 3D printed out a pelagornid bone and then put it on the ground with an outline of the pelagornid to show people. And it was like even then, it's just these birds are nuts.
Yeah.
Did they fly very similar to albatross? Would they just glided across the ocean?
Yeah, I mean, so that first one, that Protodontopteryx, the research on that indicates that was probably, did a little bit more flapping, but all the specimens after that, so pretty much every other pelagornithid, its morphology really does say that they were soaring birds. So yes, very much like albatrosses. They would just get to a height, pop out their wings, and just cruise, for vast distances. And that's, when I put that map figure up there, I mean, I just wanted to show, to really emphasize how global this group of birds was. I mean, they ranged, an incredibly long period of time from, like I said, 62 to about 2 million years. So 60 million years of Earth history. Wow. And they hit every single continent and, major land masses. I mean, this group, I think they're amazing.
Yeah.
I mean, yeah, that's like a successful group of birds to be able to exist for that long and then just spread throughout. That's so cool. And imagine what like the ancient oceans were like if people were around or whatever, but just seeing like these huge giant birds just soar across the ocean, that's like some majestic level documentary stuff.
I think if I had a time machine, I would definitely be going back to like, the Oligocene, try to find sandersi and just park on a beach with some binoculars. I probably wouldn't even need binoculars,
I'd hate to be
over you.
Yeah.
I'd hate to be under these birds after they've eaten, because just saying.
Yeah, you would definitely need a major car wash.
Yeah. Or a really big umbrella.
Yeah.
Yeah. All right. We have some great questions in the chat. Also, shout out to Santa Barbara Museum of Natural History. They are in the chat and they say hello, Peter.
Hey.
They might need your help refreshing their exhibit one day because your call outs were a great help. So
nice.
Hi to Santa Barbara. All of our museums are work with each other a lot, so it's great to see you guys. This question is from Snipe Hunter. How do we know about the keratin sheath? Is that something that's been preserved in some specimens, or something we infer from living birds?
Oh, that's an incredibly good question. Yeah, because that's one of those things that I'm interested for my own research. In these pelagornithids, so the keratin certainly doesn't preserve. It's one of those tissues that tends to get lost to time. in other specimens, in other organisms like dinosaurs, sometimes you can preserve impressions of beaks, and that's where with the pelagornithids, I'm not certain if there are keratin impressions. Thinking about the Pelagornis ori, the specimen from Santa Barbara, they do preserve feather impressions. So that's, again, feathers are made of keratin, very similarly to beaks. So there's some keratin impressions, but I don't think that one has beaks on it, or the keratinous portion of the beak. So to answer Snipe Hunter, yeah, it's a lot of inference. We see a lot of that, the pitting and grooving in modern beaked animals, so birds and turtles, and that's what leads us to hypothesize that these birds would have also had them. And as I mentioned, these pelagornithids are part of the crown group of modern birds. So they, just by relation, that's where we can infer they have a similar composition to their beaks as modern birds, which are made of bone and the keratin over top of it.
Awesome.
Are there any other birds that have convergently evolved that kind of sawtooth in their beak, or like the fake teeth in there?
So not to that extent. There are some birds that have serrations, and certainly like the range of morphology of beaks. That's something that's been noted for hundreds and hundreds of years. But yeah, so like ducks, I'm thinking of some of them have serrations in their mouths that help them to crop grass a little bit better, or even to filter out particles. I think flamingos have like a filtering mechanism, but that's all in the keratin. It doesn't go down to the bone, and so it's they're just working with the keratinous, the sheath.
That's cool.
Yeah.
Yeah.
Can you imagine a duck with a
God.
sawtooth?
No, I don't want to. I don't want to imagine that.
Yeah.
Geese are scary enough already.
Yeah.
Yeah, and that was something that I was talking with somebody recently about. Like they asked me, well, what about geese teeth? Geese have teeth, and in fact, those those aren't proper teeth. Like I was saying, they're not made of enamel and dentin, and they're not even pseudo teeth like pelagornithids because they don't have the bony component. If you've ever Googled geese teeth, which if you want to induce nightmares, then go look it up. But just trust me, it's scary. Those are papillae, just projections from the keratin that look horrible and nasty and apparently make goose bites pretty painful.
Oh, lovely.
Oh my gosh.
Did you Google it?
I just Googled it on my side computer,
no.
and I'm like, I've been chased by geese before, and I never realized what awful thing was chasing me.
You were correct to fear them.
Yeah.
Oh.
That's horrifying.
Yeah, it's not great.
They even have the little papillae on their tongue.
They do. They do. It's scary.
Why? Oh.
I'm closing
Peter,
this window.
here's another question from our curator at the Weston Science Center, Dr. Andrew McDonald. Are there any constraints that prevent modern seabirds, such as the albatross, from reaching the size of pelagornithids?
Boy, that's a great question, and I really haven't thought in that direction yet. One of the thoughts that comes to mind might be, in some regard, a bit of competition for prey. We don't know exactly what pelagornithids were eating. The best guess that we have is that they were probably skimming the water for soft, squishy things like squid and fish that could easily be swooped up. And as I mentioned in the talk, these pelagornithids, they grew to those or they evolved to those gigantic sizes pretty early in the Eocene, So this is getting to a realm where I'm a little less comfortable talking, but thinking about marine mammals, And Gabe, maybe you might have some knowledge on this, but didn't most marine mammals start to get big later in the Eocene?
Yeah, as like it got warmer. Or
Yeah.
no, well, yeah, it like there's well, because it goes up and then down, but
Okay.
like near the end of it, what they did get pretty big.
Okay.
I think it has a lot to do more with like just food resources.
Well, yeah, and so that's what I was alluding to a bit, is that maybe there's some bit of competition there with as marine mammals and and whales in particular, maybe. But again, I'm not a whale person. I don't focus on marine mammals, so I don't know the timing of that exactly. Um, so that's to get to Andrew's question, a constraint on modern albatrosses. I'm just wondering if there's some sort of resource competition that exists now that didn't when those pelagornithids got big. But yeah, I don't have a definitive answer.
What was it like when you were, starting your research and you kind of had like that aha moment for the specimen that you were studying, like, and you kind of had your question answered in your head, or it sparked that new question. What was that like for you while you were doing your research?
It was I don't even have the words. I mean, so when I started this project, as I said, one of the museum scientists at the UCMP just pointed out this specimen. She told me go check it out, and I saw it. I knew it was a pelagornithid. I felt like it had to be published, but I was fully expecting just what we would call a short communication, just a couple pages, very quick write up, something that I would be done with pretty easily, and just to get my research momentum going. Um, and yeah, it was when I started digging in. That's when it started clicking as to what size it was, and then I looked at that other specimen and how big that one was, and I mean it just kind of snowballed. And then at a certain point I realized, like, oh my, this isn't a short paper. This is something a little bit more meaty. And yeah, and it needs more time to develop it. So that's where it took me a while to put all the pieces together, my colleagues and I, to put those pieces together. And so yeah, I honestly, I don't remember the aha moment, because it was just this slow build, and things kept getting slapped on top. And it was before, at a certain point I had to step away and look at it and was like, oh my, this is big. Like, not just the specimen, but the research project itself. This is a big project.
Isn't that always how it goes? You're just like, this
Mhm.
is gonna be one thing. It's gonna be easy. And next thing you know, you're like, oh my gosh, it's been 5 years.
Yeah.
I, yeah, there were certainly many more things that could be done with this specimen and with this group. But yeah, I hit a certain point where, like, my colleagues and I were talking. We're like, no, we have to cut it off here, save all that stuff for later. We'll have to come back to it in a follow up.
Is there so like you're still you want to continue with this research even after you complete your PhD? Um, is there more places you'd like to visit or hope to find more specimens in other places?
I mean, the notion that these birds have been found all over the world. I mean, if you focus on this group, that means you're a globetrotter, and I don't mind that notion of going to see various places.
Yeah,
Um,
it's for research.
yeah,
Yeah.
exactly.
Yeah, gotta.
It's work. I have to do it. So yeah, I mean, I would love to see any of those specimens that I mentioned, like the ones in New Zealand, Chile, even the ones on the East Coast. I haven't personally been to see those. Um, yeah, I mean, there's so many questions that could be asked with this group that yeah, just traveling is easy to dream up. It's just a matter of actually making it happen.
All righty.
Any more
Okay.
questions in the chat, Britt?
I think I know what this one is, and I think it'll be quick. This is from Bill, and I think what he's asking is what happened to the pelagornithids? Like, how'd they go? Like, why do we not have 24-foot wingspan birds in the skies right now? Besides the fact that it would terrify all of us.
Yeah. So, yeah, honest answer, we don't know. We don't know what the exact cause was. As I mentioned with the youngest pelagornithid, the one from Santa Cruz, there's also some young specimens that age, time out about the same time from Morocco. Actually, I think the pseudo-tooth picture that I showed, I believe those specimens were some of these young Moroccan specimens. So that all times out right at the end of the Pliocene as we head into the Pleistocene, the Ice Age, if you will. So this is a period of massive climate change is happening. Cooling had been happening for a while before that, but it's at that Plio to Pleistocene change that some really dramatic cooling is occurring, and so that is one thought for why we don't have these birds around today. I think another thought that's been floated out is also related to competition with marine mammals, but I think that's an older hypothesis. I'm not certain if it's still floated around today.
It's because marine mammals always win.
I have a fight with also Friday chats.
Oh no! I like marine mammals. I just there's just so much research that I'm interested in that I can't do everything. I have to kind of stick to a few things so I can get some stuff out and get some stuff done.
Yeah, that's a message to all of our young paleontologists watching. That research is open for you.
Oh, most certainly. There's so many avenues to explore, so many questions to address. That we need more researchers. Well, help me out.
Well, like on that last question, let's end it with this. Like, do you have any advice for all the young future paleontologists watching or that might watch us later?
Yes, I would say if you really like fossils and if you really are interested in paleontology of whatever flavor, invertebrate, micropaleo, vertebrates, any organism in there, paleobotany, can't forget my paleobotany friends. If you're interested in that, you just stick with it. I had mentioned that I took years away between my bachelor's and my master's. I jokingly call it my gap decade. That some people talk about a gap year. I actually took a decade between my bachelor's and starting my master's, and really it was the interest in paleontology that brought me back to school. And yeah, I mean, if you really like something, and it could be science broadly, it doesn't have to be paleontology, but just stick with it. And you may take some time away, and that's okay. But if that interest is really there, you'll find a way to come back to it and make it happen. So just persevere is, I guess, where I go with that.
Aw, wonderful advice to end the new year with, for starting a new year.
Yes, thank you, Peter. Thank you for joining us.
Well, thank you for having me. I'm happy to be, I guess, the last one of the year.
Yeah, we'll close out 2020 with some big birds. Oh, perfect.
Yeah.
Peter, if anybody wants to find out more about your research or more about your lab and stuff, where can they go to find out more?
Yeah, so I'm on Twitter. My handle is @beakythings. Because I do like beaks, not just these birds, but other things. And then going to the UCMP website. So that's the UC Museum of Paleontology. And then I've got a profile in my advisor's lab page, and that's Leslie Alusko.
Yeah, sweet. We'll make sure to link all those in the description below.
Okay.
All right. Well, thanks so much, Peter, for joining us, and thanks, Brittany, for being a wonderful host for this first year. This is our first year of Fossil Friday Chat. It's our first full year.
Oh my goodness! And I hope for many more.
Yeah. Um, I totally blanked for a second. What was I saying? Oh, okay, I remember now. We're gonna close the show. That's what we're doing. So yeah, if you love Fossil Friday chats and want to support this program and programs like it at both the Western Science Center and the Alf Museum, we have links on how to do that in the description below. And as always, if you want to hear more stories from the world of paleontology, please make sure you like and subscribe to the channel. Again, this is our last episode for 2020, and we hope to see you all again in 2021. And hopefully we'll be able to go outside again soon. All right. Thanks, everybody.
Thank you, everyone.